Hello everyone, welcome. So continuing on the series about artificial general intelligence and how to achieve it. So as I asked in the previous videos, why is machine learning and artificial intelligence nowhere near human intelligence? Why is it so far so different? And I'd like to invite you for this conversation where I'm going to try to at least start the conversation about how we could maybe achieve A.G.I, what is wrong with AI, current AI and machine learning, what do we have to do to fix it, etc. Okay, so I'm Mario Lustosa, I'm the CEO of a startup. We develop applications that work with artificial intelligence. My academic background is in biology, and please, I would like to invite you to participate in this conversation. And if you haven't seen the previous videos, please do so if you'd like to. And I'm going to post more videos after this one. So please comment below, send me your ideas, any idea about A.G.I or AI that you have, comments, if you suggestions, whatever. Okay, please, I would like to try to solve this together with you, with everyone, right? So okay, let's see. So there are these points here. The first one, computers were never meant to think or understand. So what do I mean by that? You know, when computers were first thought about and developed by, you know, Alan Turing and Charles Babbage and von Neumann, you know, all the people that helped create the modern current computer. It was not a machine that was made to think, right? It was made to compute. It was made to follow instructions and do some tasks, specific tasks that were done with specific instructions, right? So we never built the computer to think. We never thought we wanted a machine that was able to think. It was able to perform specific tasks with instructions, right? So it's like any other machine, if you think about it, right? Any machine works with instructions, and then they automate the work, okay? So this is just like a computer is like a more sophisticated, I don't know, refrigerator or a car or any machine that does anything. The computer is a little bit more sophisticated or much more sophisticated. But it's still a machine that follows instructions to make specific tasks. So we never created a machine and said, oh, this machine is going to think. It's not in its hardware, it's not in its software, right? And the problem is that it was not in our intention, right? If it were in our intention, maybe we wouldn't build it with a specific set of instructions to do a specific thing. We would give it more freedom of somehow. But maybe we weren't able to create something like that was able to think, so we created something that we were able to do, which is a machine that follows instructions, right? So in the other previous videos, I talked about the approach that I suggest that we should take. One of the possible approaches, which is understanding versus brute force, right? So understanding versus brute force pattern recognition. So I talked about this in the other two videos if you want to take a look later. And so what do I mean understanding versus brute force pattern recognition? So current neural nets, they are a kind of machine that do pattern recognition, right? And that's it. That's about it. And it's brute force, so you need like 1 million images of cats so that the machine is able to recognize a cat, another image of a cat. Right? So it's just pure brute force and pure pattern recognition. That's not intelligence, right? It may be like 0.001% of what intelligence does, but that's not the whole of intelligence, okay? So I'd like to propose that instead of just pattern recognition, we need the machine needs to understand, right? But this is right now, this is like too exoteric, like this is like fantasy. how can a machine understand anything, right? But then again, why not? And if it doesn't understand anything, how can it be intelligent, right? Okay, so so I put this here beyond von Neumann architecture and current software. So my opinion right now is that maybe we can create A.G.I with current von Neumann architecture and current software, the way we think about software with neural networks and other stuff. Maybe. I'm not like ruling out, saying, oh, this is impossible. I don't know. I honestly don't know. Maybe we can do this A.G.I with current computers as we know it, right? But maybe not. So every time I talk about these things, I'm going to talk about it in the sense that as if we were to implement this in a normal computer, and I'm going to suggest that maybe we should create another kind of computer and software. So I don't know. We'll still have computers around for a long time. So, and I don't know how feasible it is to just how difficult it would be to create a different kind of computer. So I'm going to talk about the two possibilities. Usually, most of the time. But I'd like to talk a little bit about the second possibility, which is that maybe, you know, the von Neumann architecture and current software as we understand it, maybe it has hit, you know, a wall, maybe the end of the line or a wall. So what do I mean by that? Like I said, computers were never meant to think or understand. So this machine doesn't think and doesn't understand, and the way it was not built to think, right? So maybe, you know, the processor, you know, the binary code, the zeros and ones, the softwares, the lines of software with instructions, if then do this, do that. Maybe it's impossible for this architecture to reach A.G.I, right? Maybe, like I said. We're going to talk about the two possibilities, but right now I want to focus on this for a couple of minutes. And so, you know, the current architecture is very linear. It's a set of instructions, and the brain. I have this thing that I wrote down, which is the brain. The computer computes, and the brain sees. So what do I mean by that? Computer process a specific linear set of instructions without semantics, without awareness, understanding, thinking, none of that. And that's it. It computes, right? It performs instructions blindly. And the brain sees. What do I mean by that? The brain works in parallel. I'm not going to say it's a parallel computer because I don't know if the brain is a computer, right? So the brain works in parallel, processes information in parallel, many different things at the same time, and it gets the whole picture. And the whole picture is connected in the brain semantically, so it makes sense, so that it can make a decision about things and can understand one thing where it fits in the big picture, right? So the brain is a different kind of machine, right? So maybe we need a computer that is more like the brain, and maybe it needs to work in parallel. Maybe it needs more to be the information and the connections and the processing, everything. Maybe everything needs to be semantically connected, right, and processed, right, so that things fit in the whole picture, etc. So anyway, I'm going to talk, you know, more and more about these ideas about going beyond von Neumann architecture, how this could be done, why and how, etc. And I'd like to also say that current software falls almost in the same sort of category, in the same place, which is has current software, the way we know it, the way we develop it, the way we write it. Has it hit a wall as well? I don't know, maybe. So let's suppose it did hit a wall. So maybe a set of instructions, you know, is not enough anymore for us humans to solve complicated tasks like self-driving cars or finding the cures for diseases, or helping us find the cures for disease, or recognize, not just cats, but people on the street, and face recognition, and weather prediction, or whatever. So our society has reached a point where it's so complicated, so complex, that this architecture is no longer able to solve the most complex problems, right? So I guess if we started to create a new kind of computer, I suppose current and normal von Neumann computers and software would continue to exist to solve everyday problems like spreadsheets and all kinds of stuff, right? But then maybe this other kind of computer would solve to cure diseases and drive for self-driving cars, etc. Now, neuromorphic chips. So in other words, before I talk about this, so current software, just like the hardware, is a set of instructions, right? It's not parallel. It's not semantically connected. It doesn't lead to thinking. It doesn't allow for understanding. It doesn't allow for the big picture to be all connected. It's just a set of instructions. So I guess we should ask, is current software as we know it, isn't it, obsolete? Can't we think about a new way, a new kind of software, right? And I'm going to talk more about this here. I'm going to go deeper into this. But I just want to go now into neuromorphic chips, which is like, oh, okay, that's why we're creating neuromorphic chips, right? It's a different kind of chip, it's a different kind of computer, a different kind of chip. So neuromorphic chips, it's an attempt to change von Neumann architecture a little bit, I guess. But maybe it's just the beginning of an attempt, but it's not where we want to get. And here's why. Neuromorphic chips is just, here's where neuromorphic chips are. You get the neural network, right? You get the logic of the neural network software, right? The neural network is a software that works in the hardware. But you get the whole processing, the logic that goes on in the software, and you bring it down to the level of the hardware. So these neuromorphic chips, they are architected, they are created, they are developed to as if it were a kind of a neural net, So it's built to process the computing that is made on neural networks faster and better, right? So what's the problem with that? Well, if neural networks are great and very important and nice and useful, and it's an amazing breakthrough, but if it's not going to take us all the way to A.G.I, and it's based right now only on brute force and pattern recognition, which is like certainly probably not going to take us to A.G.I, then neuromorphic chips are not going to take us to A.G.I. And maybe this is not yet the kind of new architecture that we need to take us to A.G.I, right? So this is just bringing the neural network functioning down to the level of the hardware, okay? Now, giving up control. What do I mean by that? Like I said, when we created computers, the architecture, we wanted, let's put a word here, I'm not going to say slave, but like, a very obedient employee or something, right? So we wanted a machine that would just do exactly as told and nothing else, right? Line by line. So neural nets are a little attempt to give it a little degree of freedom. And that's why we've achieved amazing things with neural nets in the last few years. Just because we give it a little degree of freedom, right? It's not A.G.I, it's not thinking, it's not understanding, but it's just a little bit of freedom. So anytime we leave instructions, we get away from instructions and closer to freedom, we come closer to A.G.I. Why? as long as a machine is following instructions, it's not intelligent. That's it, right? So if you give up, we need to give up the idea that we need a machine that obeys us. It's almost egoistic, right, of us to want a machine that all the time follows our instructions. And if you want to give it intelligence and understanding, we're going to have to start giving up control. In other words, giving up a set of instructions, right? And allow it to think, to reason, to understand, to come up with conclusions, right? So the scientists, the engineers, they say, oh, the neural nets are kind of a black box. We don't know exactly what's going on there. Well, you don't need to know exactly what is going on there all the time. Why do we want to know? Because we want to have total control all the time. That's instruction, that's not intelligence, right? So we're gonna have to start giving up control to the machine to think for itself. So anyway, moving on. I'm going to talk about this later on. I'm going to explain why this is here. So one of the things that I think A.G.I. is going to need, besides understanding and thinking, which we'll break it down in the next few videos, because understanding how. We're going to discuss how, we're going to have ideas. I want to have your ideas as well. So one of the other things that I need that goes on in the brain and that I think we need to implement in the A.G.I. system, be it the old hardware and software or the new hardware and software, is that the brain is constantly updating, has a constantly updating model of the world. What do I mean by that? Like a child, for example, it's mapping the world all the time, right? It's mapping the floor, the temperature of the floor, the distance from the walls, the thickness of the walls or the doors, the weight of the objects that it grabs, and everything, right? The colors and the shapes. And so not just a child, but anyone, an adult, a brain is constantly creating these models. And if anything gets a little bit away, out of the model, we find it weird, right? So if I found, I don't know, a hole in this wall, like, when I turned around and saw a hole, I would stop and deeply analyze what's going on here. Why? Just because it's out of the model, the mapping and the model that I have of the world. Walls normally don't have holes. This wall didn't have a hole. So what is this? It's a new thing. So why is this important? The computer, right, be it any computer or computers that are working with neural nets, they are not mapping the world. They're not creating this model. So if they're not creating this model of the world, how can it understand the world? And how can things fit inside, just make sense semantically in relation to other things if you don't have a model? What is it going to be, make sense semantically? What is it going to have a relation to if there's no, reference, there's no model that it fits in? Do you understand? So maybe if we want to, so for example, I want to recognize cats, that's it. No, you need to understand the whole world and map it, and then you understand cat, right? It's not, I'm not saying we need to have a computer go around the whole world and understand everything. I'm just saying that if it needs to understand the world, its environment, right? The physics of things, the weights of things. A computer needs to be educated. I know this sounds weird, but it needs a model of the world. From this model, it's going to extract meaning and understanding and logic and thinking and everything else. And then we're going to be able to recognize objects and cats and whatever. But of course, this is a long road. But I think to create an A.G.I, you need a machine that can create and constantly update a model of the world, of the environment that it's in. And this model needs to be semantically connected. It needs to make sense semantically. So it's a lot of work, right? It's hard work. So it's not like people say, oh, we have neural nets that recognize cats. next year we're gonna have, you know, a robot A.G.I. human level. No, no, no. We just recognize cats and a few other things. There's a long road ahead, and we need to think outside the box of current software, neural nets. Otherwise, it's gonna take 200 years, right? So, narrow AI and calculators. So, narrow AI, right? Like I was saying, neural nets, etc. They're like, okay. So think of it this way: when we created the first calculators, right? It was fantastic, right? It was a breakthrough. And what did it allow us to do? Many things. Build better bridges and buildings, and calculate, you know, how big a bridge needed to be, how strong. We could do this faster. It's not that we couldn't do it with a piece of paper, but that's what machines allow us to do. Things faster, better. And for example, a truck, we can. So all these machines, they have superhuman capability, right? A calculator, a good calculator, is in the task of calculating, it is superhuman. Does it mean it is intelligent? No. A truck is superhuman in the capacity to take, you know, cargo, take load. Is it intelligent? No, it's superhuman in one narrow task, okay? So this is what narrow AI is. Yes, it is superhuman in a very narrow task, which is pattern recognition. Okay? So narrow AI is like a different kind of calculator. But of course, it's a newer kind, so it's slightly, like I said, there's a small degree of freedom and updating of its data. Still, it's like a better calculator, okay? But it's still a machine that is superhuman in a very narrow task, like calculators, like trucks, like all our other machines, okay? So A.G.I, intelligence, understanding, well, I'm not even going to go today into awareness, which is another different animal, right? But this is very narrow compared to A.G.I. So, okay, so what do we need to do? And there's a few other points here. This is what I think, there are many things I think we need to do, like a model of the world, etc. There are other things that we're gonna discuss. But I think instead of just sitting down on the computer, writing code, creating neural networks and try to make it a little better every time, I think we should just stop a little, or at least some people should stop and think more instead of coding. Instead of continuing to coding, let's just code. Someday A.G.I will arise. No, let's just stop. Let's think about intelligence, what it is, how it works. So intelligence first, right? Then building blocks. So what do I mean? If we don't know what intelligence is and how it works, how can we sit down and start to build something that we don't know how it works? First, we need to understand what it is and how it works, and then we build it. Doesn't it sort of automatically make sense? Obviously make sense? We don't know what it is, and there's very few people trying to deeply understand what it is. There's a lot of people trying to build it without knowing what it is, right? And I think this is the completely wrong approach. So intelligence first. We need to think about this. And it's not impossible. Come on, we put them on the moon. We put robots in Mars. We've constructed particles accelerators. Let's just sit down and think about this deeper. If we start to get the first ideas, logic, important ideas about this, then we crack everything else, right? So intelligence first, and then building blocks. So what do I mean building blocks? If we start to get the first insights into intelligence, we can start building the first building blocks in a sort of small scale and see if it works in the small scale. So we're not doing this and we're not testing this. We're just doing neural nets in what we've always done, right? So let's talk a little bit about Neurosymbolic AI. This is a nice progress. It's a good progress. I like it. By the way, I like what neural nets do. I honestly like it. I think it's fantastic. I just don't think that it will take us all the way to A.G.I. And so Neurosymbolic AI is very interesting. I like this progress, a recent progress in the last couple of years. What it does is it takes into account symbolic reasoning, symbolic AI. So what it does is, I'm going to show it a little bit here, and then I'm going to talk about the pros and the cons about this, okay? So David Cox, from the director of the MIT IBM Watson AI Lab, has given a presentation, and I've taken this part. I've borrowed this part. I hope he doesn't mind. Just a little. One of his slides shows a little bit something like this, and I found it very interesting. And let me just quickly try to explain. So what it does is it sort of combines neural nets with neurosymbolic AI. So with symbolic AI, neural nets with symbolic AI. So it uses a neural network to recognize shapes and objects. So it's a CNN, convolutional neural network, and it recognizes objects in a photo or in a scene. There's a scene parsing here, and it creates a structure of the information of the scene in a structured way. So ID 1, 2, color blue, red, shape, cube, sphere. Right. So after this, there's another neural net that applies language processing, and it asks a question. So we ask a question. What is the shape of the red object? So we ask the computer a question. What is the shape of the red object? The computer uses a neural net to figure out this language, and then then they use a program, right? A software, a program to do the semantic parsing here. So here's a program, filter red, right? And then query shape. And then there's this symbolic reasoning where you're going to go and filter red. And in the red, what is the shape? Shape, sphere. So using this program, using all this thing, the computer can ask a question, take a look at a scene, parse, do the semantic parsing here, and then the symbolic reasoning, and then arrive at the shape of the object, right? So, and they have achieved interesting results, better than just blind neural nets. When they do this with blind neural nets, the results are are bad, and they need millions of examples. And with this, they need very few examples, and the results are very good. So, but again, in a narrow task that it was trained to do with a specific program, etc. So I think this is very good, and I think the same way I think neural nets are great, and they're going to be used for many things, and they're going to be very important, and maybe they're a part of A.G.I, a small part that will plug into A.G.I, the neural net. So this, I think, may be another part that will plug in order for us to reach A.G.I. Okay, so this is very interesting, and it's beginning to be developed, and it's starting to be used together with neural nets. And the neural nets are starting to be able to learn a little bit about, a little semantic here, a little about symbols here and there, etc. So it's a good development, and I'm happy about this, and I'm going to follow it. And I think you should follow too. But is it going to take us all the way to A.G.I? Is that it? Is this what was missing from the A.G.I system? Like I said, I think it may be one of the things that we're going to use. It's a good thing, but I still don't think that this is going to take us all the way to A.G.I. And here's why. It's too linear. It's still software, instructions, code. It's not very general. It's tasks. It's very specific. So there's a code, there's a program. It's running the program. So the program is not necessarily understanding anything, and it's not thinking. So it's very linear, and it's like, for example, the world doesn't work with just with Q&A, questions and answer. So a computer is not just a machine to answer questions based on a little software that runs on loops that filters things, you know. So it's not just someone asking, what is the color of my hair? And the computer is going to check it out and then say, oh, it's brown. That's one part of the world, but there's other things. There's playing soccer, there's having a conversation, there's watching a movie, there's many other things that I think is going to be complicated for this machine to process, you know, and to overcome and understand, etc. So, as an example of this, we're reaching the end now of the video. So, as an example of the kind of limitation that we may have here. By the way, symbolic AI has been around since, please forgive me if I say the wrong dates, but many years, like 40, 50 years, since the 60s, 70s, something like that, since you know, Marvin Minsky's work and other people. So the symbolic AI group, people, they, as far as I know, they actually started working with artificial intelligence with symbolic AI first, with this kind of thing first, and then neural nets appeared. But neural nets have been around since the 80s. So we say, oh my God, neurosymbolic. Yes, symbolic's been around since the 60s, as far as I'm aware. And AI and neural nets since the 80s. But the only thing that changed much was that we have better computers. And yes, sure, the neural nets software is improved, the symbolic AI is going to improve as well. But, you know, this is not, oh my God, right? So even if we say, oh, this is awesome, yes. But remember, we had AI winters, you know, right? Periods of time where people thought, oh, this is amazing, we're going to reach A.G.I. tomorrow. And then there was like decades of slow progress. So we shouldn't get, just the same way that we got so excited a few years ago with neural nets, and now it's sort of like the neural nets guys are like, maybe this is not gonna solve A.G.I. And now they plug in this, it looks great, and it is great, but caution, this has been around for a while. I don't think this is going to take us all the way to A.G.I. So language is one example I want to give. It's like, oh, let's solve language. We went with Alexa or Google Assistant or whatever. And why can't we have a conversation? We're going to have a conversation now because these neural nets are going to be great, and with this neurosymbolic thing, we're going to solve language. Now, in my opinion, to solve language, you need to solve intelligence, right? In my opinion, to solve language, we need to reach A.G.I. first and then solve language, right? Why? Because I think language is the manifestation of intelligence. Language is like the vehicle with which intelligence communicates with the world, right? So language is just a vehicle. How can you solve, you know, what you need is what is being carried by the vehicle. Do you see what I mean? So the language is like a window. You don't want the window, you want to see, you know, inside the house or the world outside. So intelligence, language is like a plug-in. It's like a software that is all over the brain, right? Broca's areas, Wernicke's areas, but also the whole neocortex is involved in language. And it's like everything that is going on in the intelligent brain, right, is the language is plugged into it. So in order to have a normal, intelligent conversation, the system needs to be intelligent. There's no other way, right? So I think this is one thing that this kind of thing is still going to struggle. Yes, it may answer, you know, chatbots and cute queries or trivia, or make some cute things happen like GPT-3, which is a great development as well, but still not AGI. It does things and we say, oh, look at that, but then it breaks down. Neural nets, GPT-3, AlphaGo, whatever neural net you have, eventually if something changes too much, it breaks down. So why? There's no intelligence. The system is not understanding anything. So if there's a slight change, it can't figure out the change, understand the change, and understand what changed it. It just breaks down, right? So this, because it's limited, it's still instructions, it's still code, it's not real understanding, it's not thinking, it's not awareness. It's probably going to struggle with language. So yeah, so anyway, I'm gonna say a few more things and then we're gonna end this part. But if you want, you can take a look at the previous videos. I'm gonna post other videos because I wanna go deeper into these things and some other, many other ideas that I have about A.G.I, how to achieve it, etc. In my opinion, my humble opinion. But I'd also like your inputs, please, your comments, your ideas. Send me, I don't know, DM, send me an email, comment below, whatever. I want your ideas. If you want to make a video about these ideas or about A.G.I, please send me the link. Say, oh, I'm gonna, you know, check it out. So this is it for today. Like I said, there's a lot of things covered here. I'm gonna go deeper into some of these things, but I'm also gonna go into other new things which I haven't covered here so far, right? And how we can go about thinking about intelligence, how we can go about building these building blocks, how intelligence works. There's a whole chapter or video. I'm gonna talk about how language works, etc. How this other kind of computers could work. You know, there's many other things, but so I guess I want to invite you to this conversation. Let's see if we can come up with new things, because if we can reach at least a computer that can do better, can think a little bit for us, right? It can help us, help the world, help cure diseases, help, you know, do many things that will help society. And because we need to find cures for diseases and to solve many other problems faster rather than slow, it's urgent that we think about this and try to solve this, instead of just waiting another decade or 2 or 3 for, you know, more coding and neural nets recognizing cats, etc. We need something deeper, better, and more amazing than current computers, than current software, than current neural nets and everything else. And I want to push push you to contribute here. Let's push the boundaries. Let's think outside the box, right? I'm trying to come up with ideas, and if you have ideas, let's talk about it. And that's it for today. I hope I hope these ideas have been useful to you, and I'll see you on the next video, I guess. Okay? Thank you very much, everyone. So that's it. Bye bye.